Simply stated, the resistance of a material is a measure of its opposition to the flow of electrons. This simplified diagram of Ohm's law shows that resistance, measured in ohms, reduces the voltage's ability to produce a current. Resistance is linearly associated with equations of voltage, current, and power. In ohmic resistors, we see resistance remain constant with increasing voltage and current. However, in non-ohmic devices, such as light bulbs, as delivered power increases from either a voltage or current source, the bulb filament heats up further, increasing resistance as it dissipates more energy. This means that the voltage or current must be raised. Therefore, in non-ohmic resistors, the resistance is not constant through power changes or cycles. Resistance is an inherent property of all materials. However, engineering study focuses mainly on those materials that have a predictable and useful resistance value. Resistance is caused by collisions of electrons with the ions that they are surrounded by. Through this, we find that the probability of collision and resistance are related, and as an object is heated and the ions vibrate and take up more space, electron collisions with them are significantly raised. Therefore, we find in materials as temperature is raised, so is resistance, and vice versa. Resistance in a material is calculated using the length divided by the area multiplied by the resistivity. Another way of doing it is using conductivity, as conductivity is the inverse of resistivity. This equation shows that as a uniform material's length increases or area decreases, the resistance of that component increases, reducing current flow. Joule heating is a product of Joule's first law, stating that heating power of a component or conductor is proportional to its resistance times the square of its current, or any other form of P equals, using Ohm's law. This effect of resistance is most notably employed in electric heaters and stoves. However, often this resistive heating is not a desirable effect, and components like heat sinks, radiators, and fans must be employed to keep electronics in safe temperature levels.